All right, in this video, we are going to continue our talk about lines that we did in the last couple of videos, but in this video, we're going to discuss more specifically the idea of parallel and perpendicular lines. And so you'll see some similar ideas from the last couple of videos, but we're going to add in a couple new notations just so everybody's aware of them. So what I want to talk about first is, while we've already done a couple of videos on lines, what I want to look at next is how do you know if two lines are parallel to each other or if two lines are perpendicular to one another. So let's start with what I think is the easier of the two, and that is parallel. So what we can say is that two lines will be parallel to each other if there are two distinct non-vertical lines that have the exact same slope. So if there are any two lines that have the same slope, and remember we went over slope in the last couple of videos, they would be considered parallel to each other. And what parallel means is that they never cross each other. So as you can see in my picture to the right, these two lines, if you were to draw them infinitely in both directions, they would never cross. All right. The second kind of lines that we're going to look at in this video today are the idea of perpendicular lines. So maybe a little bit more confusing and challenging, but we're going to talk about them in detail here. If you can show me that the product of the slopes of the two lines is -1, that means that they are perpendicular to each other. Now, while that is the official definition of perpendicular, it's not usually how I go about teaching perpendicular to students. Instead, what I usually tell students in this class is that if you can see that the two slopes of the lines are negative reciprocals of each other, then they are perpendicular to each other. And so what do I mean by negative reciprocals? If your first line has a slope of -2/3, for example, if you're trying to check if another line is perpendicular to it, well, what a negative reciprocal means is you would put an extra negative, and then the idea of reciprocal is you flip the fraction over. So instead of -2/3, it would be -3/2. And we've talked about a bunch that two negatives equal a positive. And so as you can see, 3/2 and -2/3, those are what are considered negative reciprocals of each other. So if you've got two lines and those are your two slopes, those two lines would be perpendicular to each other. And so as you can see over here in my picture, when two lines cross and they are perpendicular, if you've taken a geometry class recently, or even if you haven't, it's not a big deal, they form a right angle between them. And so they cross perfectly and form like a nice square edge between the two lines. So for this video, we're going to talk in more detail, and now we're going to work some examples of how these two ideas show up. So let's begin with these two problems. If I give you a pair of lines, you need to be able to tell me if they are parallel, perpendicular, or neither. So beginning with number 1, you've got -4x minus 2y equals -9, and you've got 5x minus 10y equals 7. Now, you might remember from our previous videos in section 2.3 that when you are given the standard form of a line, like you are here, there's a shorter way to find the slope. So for each of these, and I'm going to call this M1 and M2 because you've got to find two slopes here. Remember, the formula for slope in standard form is -a/b. And so if you look at both of these problems, remember your a is always the number in front of the x, and the b is always the number in front of the y. And so if you use those numbers, we can calculate each of these slopes pretty quickly. So for the first one, you would end up having -a, so that would be the negative, and a is -4, divided by b, which is -2. Well, two negatives give you a positive, so that's 4 divided by -2, which is equal to -2. So there's your first slope. Using the same idea for the second line, you would have -a, so that would be -5, divided by b, which is -10, and -5 divided by -10, obviously the negatives will cancel to give you 5/10. And since both of those numbers share a 5 in common, I can divide them both by 5, and you get a slope of 1/2. Now, if you compare these two numbers, obviously they are not equal to each other, so they're not parallel lines, but they are negative reciprocals. Because if you take either one of those numbers, put a negative on it, and flip it over, you will get the other one every time you repeat that process. So what this tells me is that both of these lines are perpendicular to each other. That's all you have to show me. As long as you can verify that they are negative reciprocals, I know that these two lines are perpendicular. Moving over to number 2, you've got y equals -2 and 3y equals 12. Now, when you look at these, they don't look anything like the first one because these are special forms of lines we talked about in section 2.3. What you might remember is that whenever you have y equals a number, this is the form of a horizontal line. Similarly, if you look at the second one where it says 3y equals 12, even if you were to divide both sides by 3 to get the y by itself, you would get y equals 4, which also fits the form of a horizontal line that we talked about in section 2.3. Now, since both of these lines are horizontal, what you also might remember from our talk about horizontal lines is that a horizontal line always has a slope of 0. So since both lines are horizontal and thus both lines have the exact same slope, then by definition, I know that both of these lines must be parallel to each other, because not only are they the same kind of line, horizontal, that means that they have the exact same slope. All right, and so moving on to number 3, kind of moving more into writing our equations here. Number 3 says if you have a line passing through the point -2, 3, and is parallel to the line whose equation is y equals 1/4 x minus 2, I want you to use the given conditions to write the equation of your line in all 3 forms that we've learned: point slope, slope intercept, and standard form. Well, if you remember our talk in section 2.3, to write the equation of a line, you need 2 things. The first thing you need is a point, which we will call x1, y1. We have that. And the second thing you will need is a slope. Well, according to this information, the slope of our line needs to be parallel to the line given here. And so since this is already in slope intercept form, we can see the slope directly of this line based on the form. So looking at this line here, it has to have a slope of 1/4 based on the format. And since our line needs to be parallel to this line, as we just talked about, parallel lines have to have the exact same slope. So I know that our line must also have a slope of 1/4. Using just that information, we can now write the equations of our lines. So if you remember, point slope form is y minus y1 equals m times x minus x1. If I plug my numbers in, you will get y minus 3 equals 1/4 times x minus a -2. This will be y minus 3 equals 1/4 times x plus 2. And then I want to multiply the, sorry, let me stop right there. That is our point slope form. I was getting a little ahead of myself. Sorry about that. That is your point slope form. So you want to put it into the formula and then stop right there. And the reason we usually begin with point slope form is because point slope form then easily is converted into the other 2 forms. So if I move over here to slope intercept form, remember, slope intercept form means you must get the y by itself on one side. So we want to get this in the form y equals mx plus b. So from this form here, we're going to solve for y out of the point slope form. And so that would end up being y minus 3. And the part I almost jumped the gun on a minute ago, I'm going to take this 1/4 and distribute it through. So it would be 1/4 x plus 1/4 times 2. Well, this would end up being y minus 3 equals 1/4 x. And if you multiply a fourth times 2, This 2 goes into this 4 2 times and cancels, and so you'll just be left with a plus 1/2. And then to move the 3 over, we're going to add 3 to both sides, which will give us y equals 1/4 x. And then what you need to do, and I'm going to do it over here on the right, we need to add together the 1/2 and the 3. So if I take 1/2 plus 3, you'll need to get common denominator. So that would be 1/2, and I can rewrite 3 as 6 over 2. And if you add those two things together, you will get 7 over 2. So I can rewrite this as plus 7/2, and that will be your slope-intercept form. From there, you can also write standard form. So for standard form, what we will do is we need to get it into the form ax plus by equals c. You can either do this from point slope form or you can do it from slope intercept form. I'm actually going to bring over the slope intercept form we just did. So the y equals 1/4 x plus 7/2. And if you remember, in standard form, you don't want any fractions. So the first thing I'm going to do is get rid of my fractions by multiplying everything by the common denominator. So your two denominators here are 4 and 2. And so you have to multiply by the first number that they both go into. Well, 4 obviously goes into 4 and 2 goes into 4. So I'm going to multiply everything by 4. And I'm going to distribute this through to all three terms. That will end up being 4y equals 4 times 1/4 x plus 4 times 7/2. And as you can see, what happens is this 4 and this 4 cancel. This 4 divided by this 2 is 2, and you are left with 4y equals 1x plus 2 times 7 is 14. Now remember, you need the x's and y's on one side and the numbers on the other. So what I'm going to do here is I am going to kind of write really small here. I'm going to subtract the x over to the left, which will make this, I'm actually going to bring it right here. This will make it negative x plus 4y equals 14. And lastly, with standard form, the number in front of your x needs to be a positive number. So in order to change the sign of everything, I'm going to divide every term by -1. And so this will end up giving me positive x minus 4y equals -14. And so a little bit of work always on standard form, but that is your three forms of a line that come from you knowing a point and you finding the slope from the information that is given. All right, so number 4 says find the equation of a line that's perpendicular to the line 3x minus 5y equals 1 that passes through the point 1, -4, and we want your answer in slope intercept form. All right, so same idea. To write the equation of a line, you first need a point, which we have. So we will call this our x1, y1 point. The second thing you need is a slope. Now, according to this, we want our line to be perpendicular to this line. So in order to figure out our perpendicular slope, I first need to find the slope of the line that's given to us. And so remember, your slope formula for a standard form is -a over b. And so if I know that my a is 3 and my b is -5, this will be -3 over a -5, which just simplifies into 3/5. But since I want my line, or our line, I should say, to be perpendicular, we don't want to use 3/5. We want to use its negative reciprocal. So I would flip the fraction over, put a negative in front, and this is the slope along with the given point that I want to use to write the equation of our line. Now, I cannot go directly into slope-intercept form because I don't know what the y-intercept is. So what I will have to do is similar to the last problem, is I need to begin with point-slope form. And so doing that, I will end up getting y minus my y1, which is a -4, equals my slope of -5/3 times x minus 1. So two things I can do here. Number one is a double negative will make this y plus 4. And then if I take the -5/3 and distribute this, you will get -5/3 x. And then a -5/3 times a -1 is a +5/3. My last step to put this into slope-intercept form is to subtract the 4, because remember, you're trying to get the y by itself. Excuse me. This will be y equals -5/3 x. And what I'm going to do in my little scratch work over here is I need to perform this operation. So if I were to take 5/3 minus 4, I would need to get common denominators. So that would be 5/3. And if I were to rewrite the number 4, 4 is the same thing as 12/3. And so 5/3 minus 12/3 would make this a -7/3. And so that's the number that I would put into my problem. And so that's as far as you have to go. That is your slope-intercept form. That's what they were asking for. And so our slope-intercept form is y equals -5/3 x minus 7/3. Do note, you have to make sure that we did our slope as perpendicular, and also you have to make sure you write your final answer in the format that it requests. So my last slide for this video is here, question number 5 and 6. They're both pretty quick ones. This problem says on number 5, find the equation of a line that's parallel to x equals 7 that goes through the point 11, -3, and write your answer in standard form. Well, the nice thing here is that it's telling us that we want our line to be parallel to this line. Well, as we know, if two lines are parallel, they should look pretty similar, if not exact. So when we go to write this problem, the fact that our line is parallel to x equals 7, I know it's going to have an x equals because it needs to go the same way. But the difference is that our point has a different x value than the given line. Since our problem has an x value of 11, when I write my equation, your final answer should just be x equals 11. Now, both of these lines are exactly the same. They're both vertical lines, and so they should be parallel to each other, but they are different lines because you have a different value. Similarly, in number 6, you can write the equation of a line that is perpendicular to the same vertical line. Now, with this, anytime you have a vertical line and you want it to be perpendicular, this just means you have to do the other special equation. So if you remember, the other one that goes with vertical is horizontal. So if we're trying to write a horizontal line, because that's perpendicular to the vertical line, horizontal lines always have the form y equals a number. And if you look back at the same point that they gave us, the only y value in this problem is -3. So if I plug the -3 in, you will have y equals -3 as the line that is perpendicular to the vertical line that's given. And so that wraps up my video for section 2.4. In this video, we went a little bit further into the line discussion by discussing parallel and perpendicular lines. In the next set of videos, we're going to move into chapter 3 and talk about some other ideas that fall inside of this algebra course.